I already fixed the discussion forum for the sub transmission. You can check it in our classroom. As you can see here that I fixed some module in our classroom. Okay, so I hope that you already have the feedback about your mini project, about your prosthetic hand project. And I'm so impressed by your video because you speak English fluently and you also did your project with dedication. I mean, the result is quite good, very good, I think. Even though you have some problems uh, on your prototype, maybe it cannot work normally or as you expected, but you can explain the problem very clearly. I really appreciate your effort, and I'm so happy. I really enjoy uh, watching your video. Although some of you maybe forgot to submit the report, so then please check your grading, your score on this project. If you find out uh, that the first three evaluation, such as uh, research background, sketch and material, and then report, is still empty, or you don't have any grading from me, or you got the minimum score that is 60, means that I didn't found your report in the submission. So please make sure that your group, one of you, already submitted in the classroom. Or if you have problem to submit it in the classroom, please send by email to me, and I will grade your score on this project. Is it clear enough for you?
It's clear, sir.
Okay, so average, most of you got the good point, okay? Because I'm sure that you already worked hard on this project. Okay, so that's the first announcement. And then next is you will have uh, the other evaluation soon in this week. And then you also will have the third evaluation, your third quiz on this Saturday. So please spare your time to take this quiz. And this quiz cover the topic that will be covered by this quiz is soft design. And in order to prepare for that quiz, I already post exercise. Only one exercise. You can find it in the soft design discussion. And please give me a minute to explain about this discussion. Okay, so I already separate you in a different groups, and these groups only contain one person. Okay, so for example, in group one here, we have Abdul Ghani. Oh, sorry. Okay, so here for group one we have Abdul Ghani, and group two we only have Abdul Rafi Salahuddin. Means that what I expect from you is you can communicate with me about this subject, about the problem, this exercise, I mean. And I want to know from each of you how you understand about the topics, the soft design and analysis. And you cannot communicate with your friend, nor you also cannot um, see or replay to the other friends uh, forum or uh, communication. Okay, so it is a private communication between me and you. And I posed only a single question, but this question only the first step to solve the problem that given. Okay. So for example here that I ask you uh, to size the diameter of the shaft using the theory that is required here. So for example here for case A, I want you to size the diameter based on static failure analysis using distortion energy theory or so-called von Mises theory. And for case B, what is the diameter of the shaft if you apply a fatigue failure analysis? How it will be different, okay? But before going to that step, I want you to make a flowchart how you plan to solve this problem. How do you think about this problem? What is the first step to do? And in what sequence you have do it? You have to do it. So please make sure that you uh, uh, take this exercise. Okay. So to solve this first question, I will give you 30 minutes during this class. Okay, so we will spend about 1 hour to discuss about other topics. Then I will give you a 30 minutes to make a flowchart to solve this problem. Then I want to see how you think about how do you think about this problem, and then I will give you the next question or suggestion to solve this problem. So please work individually. But the main goal is that you can solve uh, sizing the diameter of the shaft. That's the final goal. But I want to make sure that each of you already understand about the concept and also the step how to apply this concept in the calculation. And I want to guide you one by one. Okay, I want to see your progress here. So in the next 30 minutes, please use it to make the flowchart. Okay. Do you understand about this?
Sir, excuse me, sir.
Yes, Sultan, please.
When we finish to make a flow chart, when
Mhm.
we where we submit it, we
Af-
submit on the discussion or
yes, please submit it in the classroom, in the forum. You have a replay button there. So please submit it in the forum directly.
okay, sir. Thank you.
And
So,
after you finish, after you take these 30 minutes, please return to the classroom. Okay, so we will take a break. We will take a break during the class, about 30 minutes, to do this problem. Then after that, please return to join with the class again. Uh, so that's what I want to do today.
okay, sir. So
Mhm.
it just to make a flow chart, sir.
Just only flowchart because I want to know how uh, how do you understand this problem and what is your strategy to solve this problem. Okay, uh, that's all. And then we can go to the next step later after the class finish because this is exercise. Okay, but I want to see your progress, each of you, to solve this problem.
Okay, sir. It's clear enough. Thank you, sir.
Mhm. Okay, how about the others? Uh, I enjoy watching your video, but I'm surprised during the class. I I rarely hear your voice. Only a few students speak here during the class.
Excuse me, sir. I want to ask about
Hmm.
the question.
Yes, please.
For this question,
Mhm.
we have to answer it in flowchart diagram, or we can also answer it in paragraph, sir.
In paragraph, it's okay. Please give the numbers.
Okay.
What is the first step? Okay.
Okay. Thank you, sir.
You're welcome. Okay, if you don't have any question, then I will start to discuss the new topics, but it is only an introduction because I want you to focus on the soft design. Okay. I have not put this material uh, in the classroom, but later you can find it there. So please make sure you download this material. Okay. I will make an annotation here. What we will learn today is about this component. We have clutch, couplings, brakes, and flywheels. Do you ever hear about this component before?
Yes, sir.
Which one? Which one, Tagalong?
The clutches, brakes, and couplings, sir.
Clutch, brakes, and couplings. So how do you think about those components? Is it the same component or different component?
They are different components, sir.
Okay, so please explain how they differ each other.
Okay, I'm sorry if I'm wrong, sir.
It's okay, it's okay. We learn here. So wrong is okay.
Never mind. I think I don't know about coupling, sir. Coupling is clutches in bahasa. Is it? But
Yes, sometimes people cannot differentiate between coupling and brakes. But please mention here, what do you understand about the clutch and coupling? It doesn't matter which one is it, but what is the function of this clutch and coupling, Irfan?
for my understanding, sir, clutches actually stop the gear in order, stop the gear or something in order to change another gear, sir.
Okay, so it is like a switch.
Yes.
For power transmission. Is that right?
Yes, it is, sir.
Okay. Where do you found this component?
On transmission?
Transmission, power transmission, vehicle, right?
Yes.
Okay, vehicle. Okay, that's good. And how about brake? This is clutch. Now about the brakes. Anyone want to try this to explain the brake?
Sir, maybe I want to.
Muhammad Adim, please.
Okay, sir. Thank you for the. Maybe I think the clutches and coupling is the same because clutches is kind of couplings because couplings is some kind of power transmission, sir. So that is transfer the power from side to the other side, sir. And
okay, so the function is the same between coupling and clutch. Is that what you mean? And the main function is to transmit the power from one component to the other component. Is that right?
Yes, sir. And then, but the clutches using the friction principle, sir. So the clutches use like friction to transmit the power, and then brakes using friction principle uh, to stop the movement, sir. Maybe.
And how about coupling?
Coupling maybe just power transmission, sir. So I think the clutches is a kind of couplings.
Okay, I understand what you mean. So you think that coupling and clutch has the same function, that is to transmit power by means of friction, but brakes is to stop the motion of component using friction. Okay, that's good observation, Adim. Anyone want to add more information about this? We will not discuss about flywheel here.
Sir, excuse me, sir. I
Yes,
want
Sultan.
to answer.
Sultan, please.
I, uh, in my opinion, the couplings is such a mechanism that we have two gears that when we desire to change gear, couplings function is for exact the connection between two gears, sir, before we go to the next gear. Uh, uh, based on my observation and based on my understanding of couplings is like this. But,
Okay.
but I rather confused about the difference for the clutches and couplings. I think the clutches is in Indonesia is personal, sir.
Yeah, it can be. Yes.
Okay. And about flywheels, flywheels in Indonesia is called roda gila.
Yes, you're right.
It's located in a machine. After when the piston is goes up and goes down, it connect with a shaft, and shaft is connected with a flywheels that will transfer the power from the machine to uh, the rod, sir. Ya pokoknya ke impellernya lah, sir. Transmit to impellernya.
Okay, to the impeller. Okay, that's good.
Yeah, thank you, sir.
Let's try, Sultan. Okay, so now let's be familiar with this title. Okay, so I'm so proud of you because you can explain the topics today. Even we still haven't start the discussion. Okay, the material. I have not teach you this, but you already understand about this function. That's very good. Okay, so let's take a look to the example here. So I know that you already familiar with internal combustion engine, even though this internal combustion engine maybe will lose its position in vehicle soon. Okay, so here we have piston, and here we have connecting rod, and here we have the crankshaft. Okay, then this crankshaft is, if we see this component in the from this left side, so here we will have this kind of structure. So the output is this crankshaft. If you give the pressure to the piston, which is induced by the explosion of the fuel combustion, so here you have the pressure work, and it will crank the shaft. So this shaft will turn and produce the torque, and it will move, or it will crank the other component. So here usually we put the gear to transmit the power to the other components in different shafts. But usually in the internal combustion engine, we often see a component that also put here without connection with other components. Only this single component works here, and it is rotating with the shaft. But then people usually take advantage from this component by put rotor and stator to put rotor and generate the electricity. We call this dynamo. The function is to generate the electricity for vehicle. But actually, this component has the other important purpose. Instead of generating this electricity, it's just the side effect. It's just another benefit from this component. Is flywheel or roda gila. Why we put flywheel here? Because we know that the explosion here is intermittent. This is intermittent, not continuously work. So if you see the in time history, and this is the explosion happen and produce positive pressure and give the output torque. But then if the piston in suction mode, then it will require pressure. So it works in negative pressure. And then the cycle is repeating between giving the output and require the input power. So if we don't put this flywheel, what we got from this internal combustion engine is the power in this pattern. So it is not smooth, and it will give you negative impression about your vehicle because the vibration will be enormous. So it is not convenient for you to drive such vehicle with this kind of output power. So that's why we put flywheel, because flywheel can absorb the kinetic energy, so the excessive one. So for example, here we only require this energy. So we have here the excessive amount of energy. Then it is absorbed by this flywheel in form of rotation. So it will have energy kinetic like this. So this energy go to the flywheel. Then when this mechanism requires the energy here, this flywheel will provide this energy. So it will substitute here. And then in this mode, using this flywheel, you can expect this kind of power, this kind of output power. So this is better than the previous one. But if you can adjust your design of this flywheel, then you can expect better than this. So you can get this kind of power. And this power is continuously delivered to to the rear tire, to the rear wheel, or to the traction wheel. So you can expect a comfortable vehicle which doesn't have fluctuating output torque from the internal combustion engine. So that's what you got from your vehicle, because you put flywheel with enough inertia to absorb the excessive energy, then apply it when the mechanism requires more energy here. Okay. So that's the function of flywheel. So the design focus on this flywheel is about how we can absorb the required energy using the appropriate inertia. Okay. And then the shape of the flywheel is usually, it has the ring where the mass is concentrated. So this is mass. But here it's just only a thin plate, or you can expect like a rim here where the mass is neglected. So this is the main mass, and this is mass is neglected because it is small. So you focus on how you designed this geometry in order to obtain appropriate inertia for the flywheel to absorb the required energy. Okay, so the step is, first know the energy to be absorbed, and then using this operation condition by the input of omega, you can estimate the inertia. Then if you get this inertia, you can modify or design the geometry, and also evaluate the strength of your design. So that's the flow to design the flywheel. Okay. Do you have any question about this flywheel? It's just an introduction. We will not go into detail in this class meeting. Do you have any question? If not, I will continue to the next component.
Maybe not yet, sir.
Okay, so it is clear enough, I hope. Okay, let's move to the next component. That is clutch. Okay, so clutch. Just like your friend said, the clutch usually exists in the gearbox for power transmission. So for example, here you have a pair of gears to transmit the power from the internal combustion engine to the driving wheel. Okay, so this is sprocket, and we'll go to the driving wheel using chain. Okay, so when you transmit the power, the torsion from the internal combustion engine to the driving wheel, it has passed through the gearbox component. So it is transmitted from one gear to the other gear, from one shaft to the other shaft. You can imagine what will happen if you change the pair of gear that transmit the power. If you change it during the input, the high input of torsion. So, I mean, if the torque produced is continuously like this, then you suddenly change or switch the gear, what will happen? If you don't use clutch or coupling, then you will have impact between this gear, okay, because the torsion suddenly changed. So for example, this is the input torsion and this is the output torsion. If the input torsion doesn't shut down at the moment, then you will have impact because you change the pairing gear. Okay. And this impact can cause failure to this tip of gear. Impact, this tip is very sensitive to the impact. So any impact load can shorten the life cycle of this gear. As we learn in the fatigue failure theory, that the type of loading will have the factor correction in the calculation. So for impact loading, it can increase the actual working stress. Means that it will reduce the strength of the material. Okay, so that's why engineers try to modify this gearbox by using clutch so that it will allow the driver to stop the input torque for a moment during switching the gear. So then the shaft will not receive the torque, but it will stop because the driver switched the gear. And then apply again. So it's like a switch, on off, on off. Okay. So how the engineer do this? So we will learn this later. And how about the couplings? It is also to transmit the power, but it is permanent. Okay. So the the characteristic is permanent. So for example, we have here the input torque, and we want to transmit it to the other shaft here, which has the output torque. If we use clutch, we can make it on off, deliver or stop, and we can control it. But for coupling, it is permanently attached and permanently work. So that it is always deliver the torque from the input to the output. So that's what we call coupling. It cannot on off, but always on. And how we deliver this torque from this shaft to the other shaft is by friction here. Or we can put bolt joint here. So the capacity, the allowable transmitted torque, will be determined by the strength of this bolt, the number of bolts, the material of bolt, the diameter of bolt in this joint. And because the working load is torque moment, so it will fail due to shear load or shear stress. You can find this when you attach the pump with the electric motor. So this is the prime mover, and you want to deliver it to your pump. So you have to use coupling here. So this coupling allows us to combine one machine with other. The prime mover with the driven component, but it is permanently. But clutch allow us to make it on-off, controllable. So that's the difference between clutch and coupling. Okay, so that's the overview. And about the brakes, I think you're already familiar with it. You already know about the drum brake, and you also know about disc brake. And in the bicycle, you have V-brake using the rubber shoe, which is stop the motion of the tire by friction between the wheel, rim, and the rubber. So, okay, now let's continue to the details. So here we will follow the outline from the machine element handbook, and the topic is arranged like this. We will do static analysis for clutch and brakes. So the purpose is to identify the working force. So how torque and force is related in the mechanism. Then we will use this torque and force information to calculate stress. And using this stress, we will evaluate the safety, the failure, by comparing with the strength of material. But here we have many subtitles because we have so many mechanisms. So clutch and brakes have different mechanisms. So the force and torque analysis depend on those mechanisms. Each type has its own torque force analysis. So that's what makes so many subtitles here. But we will not discuss all of them. We have a limited time here. Okay, so here, as we discussed previously, that clutch and brake are used to stop or transmit the motion from one component to the other component. And we can make a use of friction here. But coupling is permanent. So coupling is permanent. We just skip this because we already discussed about it.
Sir, excuse me, sir.
Yes.
I want to ask you something, sir.
Yes.
I don't really understand, sir. So clutch is compass coupling, sir?
It can be coupling in our language. So usually the mechanics call it coupling, but actually it is clutch.
Oh, I see.
And what you call compass coupling means it is the component which provide friction. So because it has friction, so sometimes eventually you have to replace it because the surface already worn out. Jadi, ya seperti itu Edgar. Apa yang kamu tanyakan tentang kampas coupling itu adalah bagian dari clutch yang memungkinkan terjadinya gesekan antar komponen.
Oh, okay, sir. Thank you.
Just wait a minute. We have some friends waiting in the to joining the class. Okay. Now let's discuss about this mechanism. This is the door stop mechanism, which will stop the motion of the door by friction. The door will make contact with this point, with this part. So the door will apply force here, and this component will have reaction force to resist the motion from the door. So here we have the reaction force in X and Y direction. And this force will be transmitted to the ground through the friction part. And because this doorstop component receives this load, then it will apply the similar load to the ground. And because we put the friction pad here, it not only has the vertical force, and it also has the friction force. So this horizontal and vertical force generate the normal force here and also the friction force here. Sorry. And what I want to show you here is how the distribution of this normal force of this pressure on the friction path affect this vertical force and affect this friction force. As you can see here that the distribution of the pressure on the ground is not homogeneous, but it is parabolic or has a function. So for example, you have U here as the position measured from this point. So here you have U, or the location of the friction path, any point on the friction path. And the pressure distribution is also a function of this position. Then the center of force, the center of normal force, then will be different if the distribution change. So for example, for this parabolic pattern or parabolic distribution, maybe the normal force will not apply in the middle, but it will on the left side or in the right side of this point, depend on the distribution. So that's why knowing the distribution of pressure on the friction path will affect our calculation in torque for clutch and brake. So the first step is to analyze what is the distribution of the pressure on the friction path, and then find at which point the resultant is applied, or which is the centroid. For example, here the centroid is in this point. Then using this knowledge, using this data, we can calculate, because we have the radius here, we can calculate what is the maximum torque that can be stopped by this friction path. So we have the torque capacity for this brake or clutch. So the maximum power to be transmitted through this clutch or brake is limited by this friction force. And this friction force is a function of the friction path material and also the distribution of pressure. So knowing this allow the engineer to modify the material of friction path to optimize the brake and clutch performance, and also by modifying the geometry of the friction path provide us higher performance of the brake and clutch. So there are two modification. You can change the material for friction path, and in our lab we have Mr. Yusuf Kailani, who researched in this topic, how to make a friction path become effective for brake. So he used the cocoa path serabut kelapa to make the composite for friction path, because cocoa path has high modulus and also high friction resistance. So this is good for friction path. But the other researcher or engineer try to modify the geometry. How if we use not continuous friction path, but rather than we make it like this, and the pattern will be arranged depend on the desired distribution of pressure. So you can use this for research also, because coupling, clutch, and brake always exist in the mobile machine, in the rotating machine. All of them always use clutch, brake, and coupling. Okay, so this is the main point from this slide. How to know the distribution of pressure on the friction path in order to determine the location of resultant force from this friction path, because this resultant will affect the torque capacity that will be delivered, that will be accommodate the power transmission. Okay, so the performance is limited by this. As you can see here, we have several scenarios for the loading. We have three different conditions here. So if we press this doorstop in left direction and push it, okay, so this force is from the door, and the doorstop will give the reaction force like this. Then we can see that what we have here, the normal force only 5.4. This is small. But if the direction of force applied on this doorstop change, then we have larger friction, normal force. We have larger normal force. And of course, the consequence is we will get higher friction force with the same geometry, only due to the change of direction. The change of direction of this input force. So in this case, we will have two definitions. We will have the self-energizing and self-de-energizing. What this means? Self-energizing means that the the force that applied on the brake or clutch will increase the frictional force. So it will make this motion lock. So this is called self-energizing because we don't apply higher braking force here. So as you can see here that we apply the same braking force. We press the brake pad with the same force by 10 Newton. But because the condition of the external load change, then we have condition where we get maximum braking force here. So we call this self-energizing. Means that this external force increase the braking force and the normal force in the mechanism. And what is self-de-energizing? It is opposite. So we apply similar load, almost similar load here with this, but what we have here different working friction force and normal force, and it is smaller compared to this. So we call this self-de-energizing because it is reduced the friction force capacity in this mechanism. This phenomena also occurs in the brake and clutch in our vehicle, in the power transmission. This is just an analog. This is just a simple example to explain about self-energizing and self-de-energizing. Maybe you also found that when your brake pad on your drum brake is already worn, sudah aus, then you push it, even you give small input force on your brake pedal, but suddenly your brake lock and your driving wheel suddenly stop. Jadi kadang kalau kalau udah aus ya sepatu remnya, kalau kita ngerem itu ditekan sedikit saja, itu tiba-tiba dia mengunci, ya, coba ngelock, sehingga mengakibatkan roda tiba-tiba berhenti berputar dan kita bisa jatuh karena kempot, ya, karena sliding, bisa terjadi skid. Nah, itu karena peristiwa self-energizing, di mana putaran roda, inersia roda itu memberikan tambahan tenaga untuk memperbesar tekanan pada permukaan brake shoe. Jadi self-energizing. Sometimes it is dangerous for us. If your vehicle suddenly stops in high speed, then you can fall down. Okay, so here is the mathematic analysis from that free body diagram. Here we have the normal force work on the brake pad. So this is the normal force, and this is the width of this brake pad. So if you see it from the top side, it has the dimension of W2 and the width is W1. So in order to obtain this normal force, you have to multiply the force distribution with the area of the brake path. Because the area of the brake path, if you take this area, you will have this relation. This is, sorry, this is the element, the width of element is du. So here you will have du. So then you have here the normal force is, we can exclude this width of brake path from the integral. Then you evaluate the integral from 0 here to the maximum here. So that's how this integral apply on this free body diagram. And then if we take the average, if we take the average of the force or the pressure, then we just use the average pressure times the area of the brake path. Means that we avoid the effect of distribution, pressure distribution. We assume that the force is homogeneously distributed like this. The pressure, I mean. But it is not true. This equation just shows to us that we can obtain the average pressure using this equation. So then, using this, knowing this normal force, allow us to find the force work in vertical direction. So that's why you found here that the reaction force in the vertical direction is affected by the performance of brake path, the friction force, the normal force created by this brake path. And also the friction force. Okay. So the friction force is the normal force times the friction coefficient. So that's how this brake path will affect the reaction force in X and Y direction. Okay, please stop me anytime if you have any questions here. Okay, so the purpose of this derivation of the formula is to obtain the condition of critical coefficient here. Critical coefficient means that when the self-locking or self-energizing happens, so self-energizing happen if, as we discussed before, that if the moment created by the friction and the external force can increase the locking mechanism, it can stop the motion. So we evaluate the moment at point A. The point A is we take the point A here in this location. Sorry. Okay. So this is the point A. We evaluate the sigma moment at point A. So here we found that this is the pedal force given by the user, and this is the normal force generated by the pressure of the friction path to the ground. And here we also have the friction force. Then we analyze the moment at point A generated by this friction force and this pedal force and normal force. Okay, so the main purpose is to find the critical frictional force. So the critical frictional force must be equal or larger with this parameter. So what is A, C, and U? U bar here. So U bar is the average position of the brake path, and C is let's take a look to the geometry again. Okay, so here we can see it clearly that the critical frictional force should be equal or larger than A, C, U bar. So we can identify that the critical frictional coefficient is a function of geometry. So means that if we already decide the component for friction path, and we already test the coefficient of friction of this path, then we can modify the geometry following this rule. So that we want to make sure that this distance times this distance means the location of the center of pressure here over the A, the length of arm here, will not exceed the critical frictional coefficient. So which one we choose? We define the material first, then modify the geometry, or we define first the geometry, then find the appropriate friction path. Both of them are work in the design of brake and clutch. Okay, so do you have any question here?
Sir, I want to ask a question, sir.
Yes, Abhi, please.
I'm sorry, about 10 minutes I was disconnected, sir. So if it already been discussed, can you tell can you tell us again how to determine the U-bar, sir?
U-bar.
Yes, sir.
Okay.
Because
Okay.
I saw the picture, it's not in the center, sir.
Okay. So for U-bar, how to determine U-bar? So for example, you have coordinate system like this, and you know the profile of pressure distribution like this. So this is P. So this is P function of U. Sorry, without bar. So this is U. For example, like this. You know this profile, the function. You must know it. Then using this function, you can take the element here and take and measure the distance from the original here. So you have U here. And you have the element, because it is very small, we call this the element of U. And the head here is PU. You just take this location into this function to obtain the head. Of course, it will change by changing this U. So then you can use centroid analysis to evaluate the location of U. So the balance of moment of area. So this area will create moment to this axis. This area create moment to this axis. So one element will create one moment here. So the area is PU DU. And the moment created by this element is UTA. This is the moment created by the element of area. Because you have many elements here, you must integrate from 0 to, for example, so this is the total moment of area due to this pressure distribution. And you can locate the U-bar in the position so that the total moment is equal to the moment created by this area. So here you apply so that you can calculate U-bar is a function of this integration. And this one. Okay, you can check your static course about this formula. I just explain again for you. That's how you find the location of U-bar.
Sure, thank you, sir.
You're welcome, Abi. Okay, do you have any other questions here? No? So let's see what kind of problem need to be solved for this case. Okay, so for example, here we have doorstop, just like shown before, and the dimension already known. I mean the geometry of the doorstop, the arm is 4 inch, and B, the horizontal arm is 2 inch, and see the distance from the beginning part of the doorstop, the brake pad to the center, to the point of A is 1 point in. We have the dimension of brake pad defined here. Then the question is, for a leftward relative movement of the floor, okay, so please be careful, means that in which direction the doorstep will move. So if the doorstep moves leftward relative to the floor, then it will affect the direction of force applied at point A. And we put the actuating force F of 10 pound of force, and we already have the material here with friction coefficient of 0.4. Using the average pressure, we have to calculate the external load, okay, the resistance load at point A on the door contact point. So what is the horizontal and vertical force allowed by this design? And how if the movement change? How if the doorstep moves to the left, okay, or rightward relative to the floor? So that's the variation of problem. So you have to find the reaction force which is related with the other component. In this case is the door, or you already know about this force, but find or design what is the appropriate brake pad to be used. Okay, so you can check by yourself the solution here, but the main point is, you know, the way of thinking here, the logic from this solution. Let's have a break here, and let's check your classroom, and please answer the question in the forum discussion. Soft design. Okay, so let's start the discussion of clutch and brake in this introduction. Okay, so it is just is the friction coefficient, pressure distribution, the geometry, and so on. Then next we will apply analysis. We will go to detail later. And now I want you to go to the classroom and check the discussion forum. Okay? And let's see you again in 30 minutes in this in this Zoom meeting, you can use the similar link in the classroom. Okay, so I will stop share and stop the class for 30 minutes. See you again in 30 minutes. Hello, thank you for joining back. So I already checked the classroom and I already answered some of discussion there. For example, here we have Irfan, Edgar, and Ivan. Okay, so let's take a look to the discussion. Okay, so this answer submitted by Edgar. Okay, what Edgar said is, let me make annotation here. In order to find the static failure analysis, to do static failure analysis, so we have to find the load, the force. Okay. So this force is generated by the gear. And second step, according to Edgar, is to find the moment at point C. Then next, to find the stress concentration factor. And then find the other factor. Then we use those information to find the maximum stress and then determine the diameter. But this step is still not clear. Okay, so what happens if we apply this force and other force if exists? Is it bending moment, which is generated by this force, or torsion, or both of them? You have to be specific in determining this load because any load can affect the size of the shaft. And then we have several points to be evaluated. But why we choose point C here instead of other points? Instead of other points, we have A, B, C, maybe D. Then why we choose C? So which point will be our focus in analysis? Why we choose this point? Of course, it must be a critical one. we have the design with homogeneous diameter. So the diameter is the same for overall length of the shaft. So we don't need to do the sizing at every area. So that means we just need to find the most critical part along this shaft. So the best way to do that is to draw the shear and bending moment and also torque diagram. So to find the critical moment, you have to find the bending moment diagram and also the torsional diagram. Then you have to plot this in two directions. So you have vertical plane and horizontal plane. So for example, here is the plane X, Y, Z. Then this is your shaft. Then you have the external force working, for example, like this. For example, we have point A, B, C, and D here. So here we have the reaction force. Then we have to find the torque diagram and bending moment diagram in this plane, in the vertical plane and on the horizontal plane. Because we have two directions for bending moment and torque diagram, so we have to find the resultant from both planes at the critical point. So we identify, we have A, B, C, and D. So one of them must be the critical point. So we have to evaluate the resultant of the bending moment and torque diagram on that point. Then choose the most critical one, the maximum resultant as the critical point. And then use this information, the maximum bending moment and maximum torsion, to evaluate the normal stress and the shear stress. Then use this information to determine the diameter of the shaft using distortion energy. Okay, you need to include this information in the distortion energy formula. The same way, the same step also required for the fatigue analysis. Okay. But for fatigue analysis, instead finding the maximum torque and maximum bending moment, you also need to define at the critical point the amplitude of bending moment and the average of bending moment. This is to calculate the amplitude stress and the average or the mean stress. And also you have to find the average, the amplitude torque to evaluate the amplitude shear, and also the average shear. then you have to use this information in the failure fatigue theories you choose. For example, Goodman combined with distortion energy. So you have to simplify this normal stress and shear stress to obtain von Mises stress, and then use this to evaluate using Goodman, for example. So that's the step required to solve this problem. So you need to be specific, and the best way to do that is by drawing the free body diagram, just like your friend mentioned here. Okay, so your friend make the step like this. First, draw the free body diagram. Then from this free body diagram, you can identify what kind of external force applied there and how many plane required to draw the bending moment and torsion diagram. So we have to evaluate this first. Then choose the maximum one to evaluate. And use this to apply von Mises theory to obtain the combined stress. Then use this to obtain the diameter for static. Okay. So this condition is not required for static. So if to do the fatigue analysis, we don't need this condition. But fatigue analysis is required if we have fluctuating load. So it doesn't relate it with the static analysis. It is different. We do static analysis if the external load is constant along the time. It's constant with time, doesn't change. But if loading changes with time, then we have to apply the fatigue failure. In this example, in this exercise, we want to obtain the diameter based on static analysis and fatigue analysis in order to compare which one is larger. Okay. And Edgar said, mentioned the result that if we use static analysis, we obtain smaller diameter compared to that of the fatigue analysis. So, for example, using fatigue analysis, we have more than 50 millimeters. But using static analysis, we only use 40 millimeters. So it makes sense, right? Because in fatigue, the strength of the material is reduced below the yield material, the yield strength, I mean. So means that we will use larger geometry, larger diameter to resist the fluctuating load. Okay, so I hope that we can continue to discuss this until the time of quiz. Okay, so but because we have a limited time here, I want to make sure that you can solve this problem step by step by tomorrow. So let's continue to discuss this exercise in the forum. I will ask you why you choose this kind of step and what is the next steps, and maybe give you a clue or question about your work uh, in the forum. Okay. So please replay and submit your answer there so that I can make sure that you understand how to solve the problem. Okay. So that I hope that you can solve the quiz with confidence. So that's how we communicate in the forum. Okay, so we can still discuss even though the lesson or the class is over. Okay, so do you have any comment or question?
Sir, can I ask a question?
Yes, Farhan, please.
Okay, does it mean in the point A of the question using the static analysis, we should not use the fatigue stress concentration factors?
Yes.
Because I found a similar question asking with this analysis. They use this concentration fatigue factor, but even if it is the static analysis, but it said that this is used to avoid localized yielding. So what does that mean?
Okay, localized yielding. Localized yielding, you can find it in the tensile test. Necking. Necking is an example of localized yielding. Jadi yang molor itu hanya bagian tertentu saja. Yang mengalami necking itu kan tidak seluruh permukaan spesimen ya. Jadi hanya pada titik tertentu saja di tengah-tengah spesimen itu yang mengalami necking. Itu namanya local yielding. But regarding the question, do we need to apply the stress fatigue stress concentration factor in the static analysis? I don't think so, because in the static analysis, there is also stress concentration factor, but not for fatigue. Okay, so stress concentration factor appear because change in diameter, and it is different for static and for fatigue, because the type of load is also different. Although it is much safer if we use fatigue concentration stress factor, because usually it is larger. Not larger. I mean, it takes the worst case on the stress concentration factor. So if you compare the stress concentration factor for static and fatigue, it is different. Okay. So for example, stress concentration factor for fatigue 0.8, but for static 0.9. So it is reduced the strength of material differently. It is reduce the strength of material differently. So I think it is okay to use fatigue stress concentration factor for static analysis because it is much safer. But it is okay, and it should be to use the stress concentration factor for static. It is enough. Okay. Both of them are applicable.
Okay, sir.
Clear,
Thank you.
Farhan? Okay.
Yeah, I think it's clear.
And regarding about that factor, correction factor, please use it properly. Means that if doing static analysis, you don't need to put factor, correction factor for fatigue, only use for static. Okay, so we have many correction factors there, but please use it properly. Okay, any other question?
Excuse me, sir.
Yes, Bella.
In the Edgar answer previously, we need to find the not sensitivity.
Yes.
And I see from the table, to get it, we need the ultimate strength and the knots radius. But we don't have the knots radius, so how we get it, sir?
For fatigue analysis.
Yes, sir.
Okay. How to obtain the knots sensitivity? It is Q, right? Sorry, let's check here. Sorry, just wait a minute. Okay, let's see what kind of information we have here. Bella said that we don't have enough information to find that kind of correction factor. So here we have its diameter, which is belong to spur gear. It doesn't affect the notch concentration factor. And then the pressure angle here, we don't need this. And this is the load here. This is strength of the material, safety factor. Okay. And this is the diameter. Okay. Bella, we need not concentration factor if we have this kind of shape or geometry of shaft. Notch concentration factor is a function of geometry change here. So you need information like D1 and D2, and also the radius of fillet, and the information about the manufacturing process of this shaft. So using those information, you can find the notch sensitivity for fatigue analysis. But here, the problem, use homogeneous diameter of shaft. Means that we don't have the stress concentration from the geometry change here. So in order to calculate the fatigue failure for notch concentration factor, we put it equal to 1. That's okay, because we don't have it here. So means it doesn't change the strength of the material. Is it clear, Bella?
So we don't need to find the Q, sir, if we already know the K?
Yes. Only use the coefficient, the constant of 1 for notch sensitivity. So if you evaluate, sorry, you have many factors here, right? So if you found that for notch sensitivity doesn't affect the endurance limit of the material because it is homogeneous, then just give it the value of 1. Means that it has no effect.
Sir, excuse me, sir.
Mm-hmm. Yes,
So in this problem, because we don't have the dimension about the fillet, we only use a correction factor from surface factor and size factor, right, sir?
Mm-hmm. Yes. And for the other factor that you consider can be neglected, so just put value of 1. So for size factor, you have to find it. And surface finish factor also, you have to find it. Is it clear for you?
Absolutely clear, sir. Thank you.
Mm-hmm. Okay, so let's continue discuss through the forum. So I will give you another exercise after you finish this. Okay, I release it by tomorrow, so you have another chance to practice before the quiz. Okay, and please work squarely. Please always draw the free body diagram because it has maximum score in the evaluation. The solution without free body diagram will be useless. Okay, will be useless. You cannot get full score without free body diagram. So please always draw this diagram. Okay, just to make sure about this. Okay, so I think we can continue our discussion via forum, and we will stop the class here. Please remember that you will do the quiz on Saturday, maybe Saturday morning as usual. So prepare yourself. And please ask me question in the forum, okay? If I found that this question important, I will send it to the others for all class members. But if it is only related to you, then I will replay it privately, just like now. So this forum also as tools for remedy for the third quiz. I mean, if you have problem in the third quiz, then I will check our discussion in this forum. If I think that you understand about the SAF, so I will add more points on your quiz based on this discussion. Why I should do this? Because first, I don't have more time to give you remedy test for the third quiz because I want to have the time for remedy for the first and second quiz. Okay. So instead of having the remedy for the third quiz, I will use this forum instead to give you extra point if you have problem in the quiz. Do you understand this?
Inshallah, sir.
Okay, so keep discuss in the forum. Okay, and don't forget for the group who get the minimum point for the report means that they didn't submit the report for the prosthetic hand. So please make sure that one of your group member submitted. Okay, so please check your first evaluation in the mini project. If you found that the first evaluation, the first evaluation, I mean, such as the research background, sketch, and material, and also report, you got 60 points, means that I didn't found your report. So please make sure that you submit it. If you have problem to submit it, please send via WhatsApp, it's okay, or via email, it's okay. So I will wait until this afternoon, okay? Do you have questions?
Maybe not, sir.
Okay, if not, then see you again on Saturday. Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam. Thank you.